Good morning. Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. The crash course that we are dealing is network analysis and transmission lines. And the topic for today is response of RLC series circuit. Lecture 9, response of RLC series circuit. Before this, let me tell you about myself. I am sravan Kumar, having 7 plus years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. Let me also explain you the Unacademy Learning App installation procedure. Type Unacademy Learning App in Google Play Store, click on install. You have the option of GATE and engineering services if you are opting for, then click on this plus, then click get subscription. You have both iconic and plus subscription. You'll get a dedicated mentor for your preparation for iconic subscription, and you can also use my code as YSK10 to get the maximum discount of 10%, and then click on this proceed to pay. Once you click on this proceed to pay, you have many payment options like debit card, credit card, EMIs, UPI, wallets, net banking. You can use any of these payment platforms and get subscription to Unacademy, the largest online e-learning platform. So let me tell you about the Evolve and Ascend for GATE 2022 and 2023. Electrical batch A both in English and Hindi starts on December 21st. We have Ankit Goyal sir, Ajay Gupta sir, Hafiz sir, BV Reddy sir and VSR Suresh sir, the top educators of Unacademy. So let me also tell you about the Unacademy Combat. It is India's largest fortnightly competition. The best questions by the best Unacademy educators. We have the challenging questions curated by our best Unacademy educators. The questions guaranteed to keep the test engaging, challenging as well as fun. So it's a super fast and fun with real-time ranking. See how you rank against each other with a live leaderboard after each and every question. Welcome Chandrakiran. Welcome Kumar. So compete with the best. Know where you stand among others contestants. You'll get a detailed video solutions by the top educators so that it will give you an in-depth video solutions for the questions right after the contestant. We have score, leaderboard, rating and awards. So do compete, crack and conquer and also win amazing prizes. The first three ranks will be given 3 months of Unacademy subscription or an equivalent Amazon voucher, and first four ranks, fourth to 50th rank, will receive a 500 rupees worth Amazon voucher. So to tell you about the Unacademy Combat, compete, crack and conquer, you can win exciting prizes, and it has largest fortnightly competition for GATE, challenging GATE questions created by the best educators, and super fast one with real-time ranking. Compete with the best, and you'll have a detailed video solutions by the top educators. Good morning, Shivakumar. So enroll for free now. Next combat goes live on 29th of December 6 p.m. Register now. You can use code crackgate to unlock, or you can also use my code YSK10. The competition format is something like this. The competition format has 60 it is a 60 minutes competition with 15 questions and 4 combats and 3 cohorts, and the relative ranking is based on the speed and the accuracy. So enroll now in Unacademy Combat. To participate in Unacademy Combat, sign in Unacademy Learning App, use the code YSK10. You can get this Unacademy Learning App by Google Play Store. Before this, let me also show you about the Ascend and Evolve batches. So we have starting new batches. Evolve for GATE 2022, Ascend for GATE 2023, and it starts from 28th of December. We have the top educators of Unacademy. Hurry up, get your subscription now for Unacademy. And the topic for today is response of RLC series circuit. Response of RLC series circuit. So let me tell you, in the previous sessions we have discussed response of RL circuit, and a response of RC circuit. And in RC circuit we have low pass RC and high pass RC, where low pass RC will act as an integrator and high pass RC as a differentiator. This is what we have seen till now. And now coming to response of RLC series circuit. Response of RLC series circuit. So the topic for today is response of RLC series circuit. So response of RLC series circuit, consider an RLC circuit with some switch like this. Consider a resistor, inductor and a capacitor with an excitation voltage like this. This is the switch which is operated like this, RLC, and there is a current. Now how do we do that? So first we'll write consider RLC series circuit. Consider an RLC series circuit. So you have an RLC series circuit. So at t is equal to 0 minus, that means if you can observe the operation of this switch, it is from off position to on position. That means at t is equal to 0 minus, it is in off. Now let's draw that. When this is in off condition, you have a resistor, an inductor and a capacitor connected like this, and switch is in off position. Switch is in off, resistor, inductor and capacitor, and the current is I of 0 minus with some voltage. What is the value of I of 0 minus now? Because it is open or off, 0 amperes. Alright, so let's write at t is equal to 0 plus. At t is equal to 0 plus, what happens? The switch is closed and you have a resistor, inductor and a capacitor. And because the capacitor does not allow sudden change of current, capacitor does not allow sudden change of voltage, and inductor doesn't allow sudden change of current. So you have V R L C. So capacitor does not allow sudden change of current, so this will be a short circuit, and inductor doesn't allow sudden change of voltage, it will be an open circuit. So you have a resistor and a capacitor in this way. So open circuit and short circuit. Even if you calculate I of 0 minus or 0 plus here, so I of 0 plus is equal to 0 amperes. So as we have calculated these two, now let us take at t greater than 0 what happens. So consider this RLC series circuit when the switch is on and you have a resistor, inductor and a capacitor. This is plus V, R, L, C, and there is current I of t. Now apply KVL to this. Apply KVL. When you apply Kirchhoff voltage law, you'll get V is equal to I into R plus L di by dt plus 1 by C integral I dt. Because this is an integral differential equation, we can convert this integral differential equation into a differential equation by just differentiating it. So differentiate with respect to t. As I have taken some input here, v, which is differentiation, will become 0. R into, you'll get di by dt plus L into d square I by dt square once you differentiate, and 1 by C into integral I dt, differentiation will get cancelled, so you'll get 1 by C into I. So can we write this as, first we'll write L d square, L d square I by dt square plus R into di by dt plus 1 by C into I is equal to 0. So let's write this in the next slide. L d square I by dt square plus, what is that? R di by dt, R di by dt plus 1 by c into I is equal to 0. I want to make this coefficient as 1, the higher order term coefficient as 1. So divide by L. So what do you get? D square I by dt square plus R by L into di by dt plus 1 by LC into I is equal to 0. Now this is a differential equation. This is a differential equation with RHS 0 and it is a second order differential equation. What is the solution of this differential equation? So solution of above differential equation is I is equal to I complementary plus I particular integral. But since RHS is equal to 0, we can say that this implies I particular integral is equal to 0. So I can write I is equal to I complementary. I is equal to I complementary. So I is equal to I complementary. So once you get that I is equal to I complementary, you need to find this I. So just try to find this I complementary. How do you find this I complementary? You find this I complementary just by, so we have the differential equation d square I by dt square plus R by L into di by dt plus 1 by LC into I is equal to 0. This is what we got, right? L d square I by dt square plus R into di by dt plus 1 by C into I is equal to 0. So 1 by C into I, we have differentiate divided the whole equation by L. So we got this equation. Can I write this as d square plus R by LD plus 1 by LC into I is equal to 0? Yes, you can write it. So what is the complementary function? You need to find the roots of this. So d square plus R by LD plus 1 by LC is equal to 0. So you can find the roots by taking minus b plus or minus under root of b square minus 4ac by 2 into a. So here the b value is minus r by l plus or minus under root of b square r by l whole square minus 4 into a 1 c 1 by lc by 2. So you can still simplify this. You can still simplify this and find the value of the roots. So you have two roots now, that is minus r by 2l plus or minus, I'm just taking 2 to the numerator, under root of 1 by 2 r by l whole square minus 4 by lc. So these are the roots d1 comma d2 if you want to say, because it is a d square, it is a second order differential equation. So you have two roots. So further if you want to simplify, you can simplify this as r by 2l minus r by 2l plus or minus, just take this 2 inside, that will become 1 by 4. So 1 by 4 r by l whole square minus 4 by 4 lc. So 4 and 4 will get cancelled. So let's write this d1 comma d2 is equal to, what is that value? Minus r by 2l minus r by 2l plus or minus under root of, see you can write this something like this, if you take 1 by 4 inside, it is r by 2l whole square, right? So r by 2l whole square minus 1 by lc, minus 1 by lc, this is what you'll get it. So I'll just denote this something like this, alpha is equal to r by 2l and beta is equal to alpha is equal to 1 by 2L, and I'll take beta is equal to, first I'll write omega naught is equal to, or omega is equal to 1 by root LC. So omega square is equal to 1 by LC. So beta will be equal to, I'm writing this as alpha. So alpha plus or minus under root of, so this value, what is this value? I can write it as alpha plus or minus alpha plus or minus under root of alpha square minus omega square, right? So I'll write this as minus alpha plus or minus beta. What is beta is equal to under root of alpha square minus omega square. So can I write it as d1 comma d2 is equal to minus alpha plus or minus under root of alpha square minus omega square. Bunny, good morning. So d1 comma d2 is equal to minus alpha plus or minus under root of alpha square minus omega square. Now let us say, if alpha is equal to omega, now let us say r by 2l. Now you'll have these roots will be different for different values of alpha and omega. If you take alpha and omega, let's say if alpha is greater than omega, you'll have one value. If alpha is equal to omega, the roots will be different. If alpha is less than omega, roots will be different. Let us see how they will vary. Now what is alpha greater than omega? Alpha greater than omega is nothing but r by 2l greater than omega. What is omega value? 1 by root LC. 1 by root LC. Alpha is equal to r by 2l is equal to 1 by root LC. Next, r by 2l less than 1 by root LC. These are the three different values. For these three different, you'll get different roots. Let us say if alpha is greater than omega, if this is greater than this value, so this value under root value will be a positive value. So you'll get roots are real and unequal. This is what you'll get it, unequal. Now if alpha is equal to beta, if this is equal to 0, so d1 d2 both will be equal to minus 1. So roots are real and equal. And when alpha is less than beta, if alpha this value is less than this, you'll get a under root of negative value, right? So this negative value will give you a complex roots. So when alpha is less than this, you'll get the roots are complex. The roots are complex conjugate. The roots are complex conjugate. So these are the three different roots that you will get. So let us consider them. So case 1, if alpha, I'll write in terms of r, that's better. R by 2l greater than 1 by root LC, that is alpha greater than omega. R by 2l whole square, alpha square greater than omega square, right? If you write this value, if r by 2l whole square, if r by 2l whole square is greater than, if r by 2l whole square is greater than 1 by root LC, this value will be, roots will be, what are the roots? Roots are real and unequal. So let us call those roots as d1 is equal to, if this is positive, so you have beta. So minus alpha plus or minus beta. So you'll get d1 is equal to minus alpha minus beta and d2 is equal to minus alpha plus beta. So this beta value is a positive value. Then what is the response of the system? Or when, what is I of t? So I of t will be, I of t versus t. I of t versus t will be a over damped response like this. This is an over damped response. Similarly, if you take the other case, case 2, if this r by 2l whole square is greater than 1 by LC, r by 2l is greater than 1 by root LC, then what are the roots? Roots are, this is also, roots are real and equal. So you have d1 comma d2 is equal to minus r by 2l plus or minus under root of r by 2l whole square minus 1 by LC. So if these two are now equal, let us say the second case is they are equal. Now these two values will be equal. So you'll get minus r by 2l. That is d1 is equal to minus alpha, d2 is also equal to minus alpha. So this is called as a critically damped system. So this is called as a critically damped system whose response is like this. I of t versus t. If you draw it, you'll get a critically damped response. So this is critically damped system. Now let us consider case 3, when you have r by 2l is less than 1 by root LC. R by 2l less than 1 by root LC. So what will happen? d1 comma d2 is equal to minus r by 2l plus or minus under root of r by 2l whole square minus 1 by LC. If this r by 2l is less than this value, this under root value will be a negative value. So you'll get minus alpha plus or minus j beta. That's what you get it. So d1 is equal to minus alpha plus j beta. d2 is equal to minus alpha minus j beta. So the what are the roots here? Roots are complex conjugate. Complex conjugate roots, you'll get it. So when the roots are complex conjugate, the response is an underdamped response. What is that response? It is an underdamped system. It is an underdamped system. That's what you'll get it. So what is the response? Let's try to draw that. So you'll get an underdamped system response wherein the oscillations will be reducing with respect to time for I of t. Now let's try to write the solutions for all these. Now when the roots are real and see this is for I, right? So this solution is to be written for I. So I complementary we are trying to find. So these are the different roots. So what is I complementary for all these cases? So let's try to write I of t or I complementary is equal to what is that? Roots are real and distinct. So it is k1 into e power minus alpha minus beta into t plus k2 into e power minus alpha plus beta into t. Right? So this is an exponential function. So let's try to write when it is equal. Roots are equal. So what is I of t? I of t is equal to k1 plus k2x into e power minus alpha t. c1 plus c2x into e power at when the roots are real and equal. That is what you'll write it, right? So this will be the response. Now if you take the next one, for this if you want to write I of t, what is that? A plus ib. So e power alpha t into k1 cos beta t plus k2 sin beta t. So exponential multiplied by a cosine and exponential multiplied by a sine. So that's the reason you'll get an underdamped system response. So the solution of response of an RLC series circuit has the following three. One is I of t is equal to k1 into e power minus alpha minus beta into t plus k2 into e power minus alpha plus beta into t. Second, I of t is equal to k1 plus k2. This is k1 plus k2 t. So k1 plus k2 t into e power minus alpha t. And the roots are real and equal. Next, I of t is equal to e power minus alpha t into k1 cos beta t plus k2 sin beta t. So these are the three different responses that you get. This is when roots are real and unequal. This is when roots are real and equal, and this is when roots are complex conjugate. So these are the four different conditions or the four different responses based on the roots, or this is when we can say r by 2l is greater than 1 by root LC, and this is when r by 2l is equal to 1 by root LC, and this value will get when r by 2l is less than 1 by root LC. So this is the response of RLC series circuit for step input, you can say. So next we will consider one problem. Obtain the expression for current I of t for t greater than 0. Obtain the expression for current I of t for t greater than 0 if the switch is closed at t is equal to 0 in given network. So if you observe that there is a given network that is given an RLC series network with 10 volts. RLC is given, and the value of resistor is given as 9 ohms, and this is 1 Henry. This is 0.05 farad. Switch is operated like this, and the voltage is 20 volts. So here we are asked to find I of t for t greater than 0. So first we'll write at t is equal to 0 minus. At t is equal to 0 minus, switch is off. When the switch is off, this is 20 volts, resistor 9 ohms, inductor 1 Henry, capacitor 0.05 farad. So what is the value of I of 0 minus? I of 0 minus through this is loop is equal to 0 amperes. I of 0 minus is equal to 0 amperes. I of 0 minus is 0 amperes. Now let us consider at t is equal to 0, t0 plus. So when t is equal to t0 plus, switch is on. There is a resistor, inductor and a capacitor. Now this value is 20 volts, 9 ohms, 1 Henry, 0.05 farads. But if you observe, as the capacitor does not allow sudden change of voltage, it will be a short circuit, and inductor does not allow sudden change of current, it will be an open circuit. Even in this condition, if you try to find the current I of 0 plus, so I of 0 plus will be 0 amperes. Now even if you write voltage across capacitor, in this case VC of 0 minus is 0 volts, and even if you write VC of 0 plus is 0 volts. So inductor does not allow sudden change of current and capacitor does not allow sudden change of voltage. Now let us consider at t greater than 0. At t greater than 0, the circuit switch will be on, switch is on, and you have a resistor switch is on, you have a resistor, inductor and a capacitor connected to the supply, and the value of supply voltage is 20 volts, resistor 9 ohms, inductor 1 henry, capacitor 0.05 farads. Now if you try to find the current I of t, apply KVL to this equation, apply KVL to the circuit, apply Kirchhoff laws to circuit. So if you apply Kirchhoff's voltage law, what will happen? 20 is equal to 9 into I plus L di by dt. So first I'll write that in terms of RLC, then we'll write the equation. So it is V is equal to R into I plus L di by dt inductor plus 1 by C integral I dt. So what is V? 20 is equal to I into 9 into I plus L 1 into di by dt inductor value plus 1 by 0.05 integral I dt. Right? So once you do that, just because it is an integral differential equation, because that is an integral differential equation, you need to differentiate it. You need to differentiate it. So differentiating with respect to t. So differentiating with respect to t, what will happen? We'll get a 0, differentiation of 20 is 0, 9 into di by dt plus 1 can be d square I by dt square plus 1 by 0.05 is equal to 100 by 5. That's what you'll write it, right? So 100 by 5. So this is 5 2s are 10. So it is 20, right? So 20 is, this is 20 integral I dt. Now let's try to write this in the next slide. So we got 9 di by dt plus, what is the other value? D square I by dt square plus 20 integral I dt is equal to 0. So you can write this equation as d square higher order term first plus 9 di by dt plus, sorry, when you differentiate this, you will not get integral here. Integration differentiation will get cancelled. So it is 20 into I. When you differentiate this, you will get 20 into I. So therefore, here also you will get 20 into I is equal to 0. So this is 20I is equal to 0. Can I write this as d square plus 9d plus 20 whole into I is equal to 0? Yes. Hi Karthik, welcome. So this is a second order differential equation. Now you need to find, as you know, the response of the system will depend upon the, so what is the response or the solution of this? Solution of above differential equation is I is equal to I complementary plus I particular integral. So this is d square plus 9d plus 2 into I, sorry, 20. So this is 20 into I. So 20 into I is equal to 0. You don't have IP. I is equal to IC plus IP. But IP is equal to 0. But IP is equal to 0 since RHS is 0. Directly you can write it. So I is equal to only IC. So we need to find what? We need to find IC. So to find IC. So how do you do that? Take the auxiliary equation. F of m is equal to 0. What is that? M square plus 9m plus 20 is equal to 0. Now try to find its roots. Swapna, good morning. Minus b plus or minus under root of b square minus 4ac by 2a. This is in the form of ax square plus bx plus c, where a value is 1, b value is 9, c value is 20. So this is m1 comma m2, two roots. So minus 9 plus or minus 9 nines are 81 minus 4 into 1 into 20 by 2 into 1. So let's see what are the roots. M1 comma M2 is equal to minus 9 plus or minus under root of 9 square minus 4 into 1 into 20 by 2. So M1 comma M2 is equal to minus 9 plus or minus under root of 81 minus 80. 40 4 into 20 80 by 2. So what you'll get, m1 comma m2 is equal to minus 9 plus or minus 1. Root 1 is 1 by 2. So m1 is equal to minus 9 plus 1 by 2 and m2 is equal to minus 9 minus 1 by 2. So what is this value that you get? So this m1 is equal to minus 8 by 2, m2 is equal to minus 10 by 2. So the roots are real and unequal. This is minus 4 and this is minus 5. So you got the roots as m1 is equal to minus 4, m2 is equal to minus 5. What is that roots we got? Roots are real and unequal. So what is the solution? I of t is equal to k1 into e power minus 4t plus k2 into e power minus 5t. k1 into e power minus 4t and k2 into e power minus 5t. Let's try to find these values of k1 and k2. So to find the values of k1 and k2, you need to substitute the initial conditions. Soumya, good morning. Welcome to Unacademy. So k1 into k1 into e power minus 4t and k2 into e power minus 5t. So let's try to find these values from the initial conditions. So let's first try to differentiate this. So differentiate with respect to t. What you'll get? Di of t by dt is equal to k1 into e power minus 4 into e power minus 4t plus k2 into minus 5 into e power minus 5t, because differentiation of e power at is equal to a into e power at. Differentiation of e power at is equal to, but we know that di by dt value at t is equal to 0. So at t is equal to 0, di of t by dt, that is 0. So once you substitute that, you will get 0 is equal to k1 plus k2. You will get k1 plus k2. So let's try to write this in the next slide. So we got I of t is equal to k1 into e power minus 4t plus k2 into e power minus 5t, and di of t by dt is equal to minus 4 into k1 into e power minus 4t plus minus 5 into k2 into e power minus 5t. Now we already know that at t is equal to 0, I of 0 plus is equal to 0 amperes. That we have already found. If you see, this is 0 volts and 0 amperes. This is also 0 volts and 0 amperes at t is equal to 0 plus. So let's try to substitute that here. Now if you substitute t, I of t is 0, k1 into e power minus 4 into 0 plus k2 into e power minus 5 into 0. So this will get 0 is equal to k1 plus k2. Now this, once you get this k1 plus k2, at t is equal to 0, let us try to find di of 0 by dt. That is, if you substitute t is equal to 0, this is minus 4 k1 minus 5 k2. Putting these values in, now let us consider the equation. The first differential equation that we got, it is 20 is equal to 9 into I plus 1 into di by dt plus 1 by 0.05 integral I dt. Now let's try to substitute that here. At t is equal to 0 plus 20 is equal to 9 into I of 0 plus di of 0 plus by dt plus 1 by 0.05 integral I of 0 plus dt. So this will be di of 0 plus by dt is equal to 20 minus 9 I of 0 plus, and integral this I of 0 plus value is 0, that is equal to 20 ampere per second. So this value is also 0. Therefore, di of 0 plus by dt value is 20 ampere per second. So just substitute this value of di of 0 plus by dt here. So 20 is equal to minus 4k1 minus 5k2. So we have two equations here, k1 plus k2 is equal to 0, minus 4k1 minus 5k2 is equal to 20. So k1 is equal to minus k2, just substitute it here. So minus 4 into minus k2 minus 5k2 is equal to 20. 4k2 minus 5k2 is equal to 20. Minus k2 is equal to 20. K2 is equal to minus 20. When k2 is equal to minus 20, k1 is equal to plus 20. Therefore, you know I of t is equal to k1 into e power minus 4t plus k2 into e power minus 5t. We got k1 is equal to 20 and k2 is equal to minus 20. Therefore, what is the solution? Therefore, I of t for t greater than 0 is I of t is equal to k1 20 into e power minus 4t plus minus 20 into e power minus 5t. So I of t will be 20 e power minus 4t minus 20 e power minus 5t. So this is the solution for the given question. So how did we do this? Let's try to solve once again one by one. So we are given a circuit. Obtain the expression for I of t for t greater than 0 if the switch is closed at t is equal to 0. So we have written at t0 minus values of I0 minus and Vc of 0 minus. Then at t0 plus also we have calculated these values. Then at t greater than 0 we try to apply KVL and obtained an integral differential equation, and this is the differential equation that we got by differentiating it with respect to t. With respect to t, if you differentiate you'll get this, and this has an RHS 0. You can also write this differential equation as t square plus 90 plus 20 into I is equal to 0. It has both complementary and particular integrals. So particular integral will be 0 because RHS is 0. So the solution is I is equal to IC. Complementary function is found by considering the auxiliary equation. So you'll get, it is a quadratic equation, so you'll get two roots. So we got two roots as minus 4 and minus 5. So the solution will be k1 into e power minus 4t and k2 into e power minus 5t. So you can differentiate this and write the equations. So then after this we have taken these two. This is I of t is equal to k1 into e power minus 4t and this differential term, and we have applied at t is equal to 0. I of 0 plus is 0, we already know that. From that we got an equation, and for this also at t is equal to 0 plus we tried to apply di of 0 plus. So at t is equal to 0 you'll get di of 0 plus by dt is equal to minus 4k1 e power 0 is 1, e power minus 5t e power 0 is also 1, so minus 4t. Krishnachari, good morning. So you got two equations, and then you need to find k1 k2 values. So in order to find that, we will consider this equation, the same equation that we got while applying KVL. At t is equal to 0 we'll try to find di of 0 plus by dt. This we have already learned in initial conditions topic. So we'll get di of 0 plus by dt. Once we get the di of 0 plus by dt, substitute it here, you'll get 20 is equal to minus 4k1 minus 5k2. Then you, if you solve, you'll get k1 value and k2 value as 20 and minus 10. Then we substitute the values of k1 and k2 in this I of t again. So the solution of I of t is obtained like this. So this is how we will solve an RLC series circuit given to us. Similarly, we shall solve one more question. So the next question, let us consider one more question like this. So the question is, in the network shown, switch is moved from position 1 to position 2. Switch is moved from position 1 to position 2. Switch is moved from position 1 to 2 at t is equal to 0. And it is also given that switch is at position 1 for long time. Determine the expression for current. This is the question. Determine the expression for current I of t. So the circuit is given like this. Let's try to draw the circuit. The circuit is, you have a 20-volt source and there is a switch here. You have a 50-volt source. This is the switch. It is operated from 1 to 2. This is one position, this is two position. You have a resistor, inductor and a capacitor. Resistor, inductor and capacitor, and these values are given as, this is 20 volts, this value is 50 volts, resistor value 10 ohms, 2 Henry and 3 Farad. So let's try to do that. So first we will try to do at t is equal to 0 minus. What is the position of switch? Switch is at position 1. And how much time it is at position 1? It is for a long time, right? So it is at position 1 for a long time. So when it is at position 1 for a long time, so this is the position. You need not draw this 50-volt source. So you have a resistor and an inductor and a capacitor. Let's see what happens to them a little later. But for now, you have these things. So this is 20 volts, resistor 10 ohms, inductor 2 Henry, capacitor 3 farads. And you also have a 50 volts, which I'm not considering now because the switch is at position 1 now. So when this is the case, when it is for an infinite time, this inductor will act as a short circuit and capacitor will act like an open circuit, and the voltage across capacitor is 20 volts. So what is that value of current in this? I of 0 minus will be 0 amperes, but the voltage across capacitor will be 20 volts. Now let us try to do at a t0 plus. Let us try to do at a t0 plus what happens. At a t0 plus, this 20 volts is disconnected and the circuit is now connected to 50 volts. You have a resistor, inductor and a capacitor. Because the capacitor does not allow sudden change of voltage, it will still have that voltage and it will act as a voltage source of 20 volts. This is 50 volts and the resistor value is 10 ohms. So voltage across capacitor V0 plus is 20 volts. and current through the circuit is 0 amperes at T0 plus instead of T0 plus, because inductor and capacitor does not allow sudden change of current and voltages. We'll get the same values. What is that? V of 0 plus is equal to 20 volts, I of 0 plus is equal to 0 amperes. Now let us consider at t greater than 0. At t greater than 0, switch is at position. What is the position of the switch? Switch is at position 2. So let's try to draw that. This is 50 volts, position 2. You have resistor, inductor, and here you have a capacitor along with voltage source, because it is already charged, right? So the value of this is 50 volts, this is 20 volts, the value of capacitor is 3 farad, inductor 2 Henry, and resistor 10 ohms. Now let's try to apply KVL in this equation. So apply KVL. What happens? 50 is equal to 10 into I plus 2 into di by dt plus 1 by 3 integral I dt plus 20. So let's write this equation in the next slide. So this 50 is equal to 10 into I plus inductor value 2 into di by dt plus 1 by 3 integral I dt plus 20. So if you take 20 to the other side, it will be 30. 50 minus 20 is 30, is equal to 10 into I plus 2 di by dt plus 1 by c integral I dt. So because this is an integral differential equation, differentiate with respect to t. So this will be 0 is equal to 10 into di by dt plus 2 into d square I by dt square plus 1 by 3 into I. So you can still write it as 2 d square I by dt square plus 10 di by dt plus 1 by 3 into I is equal to 0. I want to make the coefficient of this higher order term 1. So I am writing this as d square I by dt square plus 5 di by dt plus 1 by 6 into I is equal to 0. Now this is a differential equation, that is d square I by dt square plus 5 into di by dt plus 1 by 6 into I is equal to 0. I can write this differential equation as d square plus 5d plus 1 by 6 into I is equal to 0. And what is the solution of this? Solution of this differential equation is I is equal to I complementary. I naught plus I particular is equal to 0. Now from this you need to find the roots. So minus b, you'll consider auxiliary equation first to find I complementary function. What you'll do? F of m is equal to 0. That is m square plus 5m plus 1 by 6 is equal to 0. So let's try to write these roots. Minus b, well, direct minus b plus or minus under root of b square minus 4ac by 2 into a. So what is this value? Minus 5 plus or minus under root of 25 minus 4 into 1 into 1 by 6 by 2 into 1. So this is minus 5 plus or minus under root of 2 2s are 2 3s are 25 into 3 75 minus 2 by 3 73 by 3 by 2. Now what are the roots that you will get? So m1 is equal to m2 is equal to minus 5 plus or minus 5 plus root 73 by 3 by 2 minus 5 minus root 73 by 3 by 2. Therefore you'll get m1 comma m2 is equal to, you'll get two roots as minus 0.03 comma minus 4.97. So the roots are real and unequal. Roots are real and unequal. When the roots are real and unequal, what is the solution? I of t is equal to k1 into e power minus 0.03t plus k2 into e power minus 4.97t. But still you need to find the values of k1 and k2. So we already know that at t is equal to 0 minus and 0 plus, I of 0 plus is equal to 0 amperes. So let's try to substitute that. So let's try to do that. At t is equal to 0, I of 0 plus is equal to 0. Once you substitute that, what you'll get? I is equal to 0, k1 into e power minus 0.03t is 1 plus k2 into e power minus 0.032 is 1 again. So that will be 0 is equal to k1 plus k2. So this value is also 1. This value is also 1. So this is one condition. Then you need to differentiate this term. Then differentiate this. We'll write this again. So what is I of t is equal to k1 into e power minus 0.03t plus k2 into e power minus 4.97. What is that value? 4.97t. Differentiate with respect to t. What is that? Di of t by dt is equal to k1 into minus 0.03 into e power minus 0.03t plus k2 into minus 4.97 into e power minus 4.97t. Right? So this is the differential equation. So we need to find di of 0 plus by dt at t is equal to 0. This is k1 into minus 0.03 into 1 e power 0, k2 into minus 0.47 into 1. You'll get di of 0 plus by dt is equal to minus 0.03 k1 minus 0.49 k2. Now you need to find di of 0 plus by dt. So consider the first equation that we got. What is the first equation that we got from the differential equation? If you observe, yeah, this is the equation. 30 is equal to, so this is 30 is equal to 10i plus 2 di by dt plus 1 by 3 integral I dt. So 30 is equal to 30 is equal to, what is that? 10i plus 2 di by dt. 10i plus 2 di by dt plus 10i plus 2 di by dt plus 1 by 3 integral I dt. 1 by 3 integral I dt. So at t is equal to 0 plus I of 0 plus is equal to 0. Substitute that. 30 is equal to 10 into I of 0 plus 2 into di of 0 plus by dt plus 1 by 3 integral I of 0 plus. So this will give you 2 into di of 0 plus by dt is equal to, this value will be 0. This value will also be 0, is equal to 30. So I'll get di of 0 plus by dt is equal to 15 ampere per second. So just substitute this value here. This is 15 is equal to minus 0.03 k1 minus 0.49 k2. So you got two conditions. One is k1 plus k2 is equal to 0. So let's try to take that. K1 plus K2 is equal to 0 minus 0.03 K1 minus 0.49 K2 is equal to 15. If you try to solve this, K1 is equal to minus K2. So minus 0.03 into minus K2 minus 0.49 K2 is equal to 15. So this is plus 0.03 K2 minus 0.49 K2 is equal to 15. So just try to simplify this. You'll get this value as 0.49 minus 0.03, that is minus 0.46 K2 is equal to 15. So 15 divided by 0.46. So K2 is equal to minus 32.6. Therefore K1 is equal to 32.6. So once you have got these values of K1 and K2, substitute them back in this. We'll write this equation. I of t is equal to K1 into e power minus 0.03t plus K2 into e power minus 4.97t. So we got K1 value as 32.6 and K2 value as minus 32.6. So I of t is equal to 32.6 into e power minus 0.03t minus 32.6 into e power minus 4.97t. So this is the current expression for t greater than 0. This is current I of t for t greater than 0. I of t for t greater than 0 for the given question. Then let's see how we have solved this. This is the question that is given. In this, switch is moved from position 1 to position 2. When this is moved from position 1 to position 2, so we have 20 volts source that was previously connected and it was for a very long time. It was for a very long time. So we have considered I of 0 minus and Vc of 0. Then we try to find t at t0 plus the values of I of 0 plus and V of 0 plus. You got the same values because capacitor does not allow sudden change of voltage and inductor doesn't allow sudden change of current. So then at t greater than 0 we apply this second position, we apply KVL. So when we apply this, you'll get 30 is equal to 10i 2 di by dt 1 by 3. This different integral differential equation. Differentiate it, you'll get a differential equation. Then to this differential equation, we need to find its solution. The solution is I complementary because I particular will be 0 since RHS is 0 here in this case. That's how you'll get M1 and M2 values and you'll write the solution of I of t. But still you need to find K1 and K2 value. So substitute at t is equal to 0. What is the value of I? Then you'll get K1 K2 relationship. K1 value and K2 value can be found. You also need to substitute the other condition at di of 0 plus by dt. So you'll find di of 0 plus by dt from the equation that we obtained first. Then we write the di of 0 plus by dt value, and hence we will find K1 K2 values as 32.6 and minus 32.6, and if you substitute them back in this equation you will get I of t. So this is how you will solve a question. So now let's try to look at the other question. So before this, let us solve RLC parallel circuit. Let us consider response of RLC parallel circuit before going to the next problem. So once we are done with this, we'll go to the next. So let us consider a parallel circuit with a current source, and there is a switch operation that is like this, and you have parallel RLC, you have a resistor and an inductor and a capacitor. So this is the value. Let me write those values. Yes, so this is the circuit. So value of this current, let's take it as I, this as G, L and C. Conductance we have considered. So let this switch be operated. Let this switch is opened at t is equal to 0. Current source is connected to the circuit, applying KCL at the node. So we will consider, a parallel RLC circuit. Once you consider this parallel RLC circuit, and let us assume switch is opened at t is equal to 0. So previously switch was closed. Now apply KCL at this node. All these are same nodes. When you apply KCL, you will get, if this is voltage V of t here, this is G into V of t plus 1 by L into integral V of t dt plus C dV of t by dt is equal to I. So let's write this equation once again. So current I is equal to G into V of t plus 1 by L integral V of t dt plus C dV by dt. Now because this is an integral differential equation, differentiate with respect to t. So you'll get I differentiation constant value 0, G into dV of t by dt plus 1 by L V of t, differentiation integration will get cancelled, C d square V of t by dt. Now this is a differential equation, second order, d square V of t by dt square plus G dV of t by dt plus 1 by L into V of t is equal to 0. So this is the differential equation. What is that? D square V by dt square plus G dV by dt. I'm just writing instead of V of t V. So other one is 1 by L into P is equal to 0. Can I write this equation as d square? You have a C here. I want to divide the whole equation by C. So this is C. You have C here. I have divided the whole equation by C. So you'll get, yeah, so G by C plus 1 by LC into V is equal to 0. So this is a differential equation, second order differential equation. So d square plus G by C plus 1 by LC is equal to 0. So what are the roots of this? Minus B plus or minus under root of B square minus 4AC by 2 into A. J value is 1. So you can write this as minus B. What is minus B? Minus G by C plus or minus under root of G by C whole square minus 4 into 1 by LC by 2 into 1. So the roots are the same way you can write d1 comma d2. If you just simplify this, you'll get it as minus G by 2C plus or minus under root of G by 2C whole square. I am taking 2 to the numerator and taking into the square minus 1 by LC. And based on this also you will get G by 2C, it is greater than 1 by root LC. You can also write it as 1 by root LC whole square is greater than this. Then what is the roots? Roots are real and equal. roots are, write this in the next slide better. So let's take this to the next slide. Yeah. So you have two roots here. One is d1 comma d2. You can write it as minus g by 2c plus or minus under root of g by 2c whole square minus 1 by root ELC whole square. So let us consider g by 2c as alpha, and let alpha is equal to g by 2c and beta is equal to 1 by root LC. So if alpha is greater than beta, what happens? If alpha is greater than this value is greater than this value, roots are real and unequal. And what will be the roots? Let us consider this as d1 comma d2 is equal to minus g by 2c is alpha plus or minus, if you just simplify this, let us assume that it is p. What is p? It is the difference of, let us consider p is equal to alpha square minus beta square. P is alpha square minus beta square. So this is one root will be alpha plus p, other root will be alpha minus p. This is the first case. Now let us consider the same. If alpha is equal to beta, so we got d1 comma d2 is equal to minus g by 2c plus or minus under root of g by 2c whole square minus 1 by root LC whole square. So we have considered d1 comma d2 is equal to minus alpha plus or minus under root of alpha square minus beta square. So if now alpha is equal to beta, if case 2, if alpha is equal to beta, what will happen if alpha is equal to beta? d1 comma d2 will be equal to minus alpha. That means d1 is equal to minus alpha, d2 is also equal to minus alpha. So the roots are real and equal. So the solution will be, we'll also write the solution. What is the solution? V is equal to k1 plus k2t into e power minus alpha t. In the previous case also, let's try to write the solution V, because this is a differential equation in terms of V. So we'll write V is equal to k1 into e power alpha plus p, this is minus alpha plus p, let's take it as, so minus alpha plus k2 into e power minus alpha minus p into t. Now let us consider the third case. So d1 comma d2 is equal to, I'm writing directly, alpha plus or minus under root of alpha square minus beta square. Now let us say alpha is less than beta. if alpha is less than beta, what will be d1 minus d2? It will be minus alpha plus or minus jp, where p is equal to alpha square minus beta square. If alpha is less than beta, p will be a negative value. Root of negative value will give you j. So d1 is equal to minus alpha plus jp and d2 is equal to minus alpha minus jp. So what is the solution for this equation? V is equal to e power minus alpha t into k1 cos pt plus k2 sin pt. So these are the different solutions for a parallel circuit. So what have we done? We have considered a parallel circuit where the switch was closed for a long time and it is open, and inductor and capacitor are assumed to be uncharged. So we have written applied KCL to this node. Then you got G into V, conductance into voltage. This is another current. This is a current through capacitor, current through inductor. This is current through conductance. So we'll get a integral differential equation, convert that into differential equation and divide by C to make the coefficient of higher order derivative as 1. Then for this you have two solutions. One is V is equal to V complementary plus V particular, because RHS is 0, you don't have it, and based on the value of this under root value, the solution will vary. So we have considered the first case as alpha greater than beta where the roots are real and unequal, and we got v is equal to. And similarly, when alpha is equal to beta, you got real and equal roots, and this is the solution. If alpha is less than beta, these are the two roots. What are the roots here? Roots are complex conjugate. Roots are complex conjugate. So you have to write the solution in this way. So these are the different ways of writing this. Now let us consider one problem and try to solve it. The switch is closed and a steady state is reached in the network at t is equal to 0. Question is, switch is closed and steady state is reached at t is equal to 0, and then switch is opened. Then switch is opened at t is equal to 0. Find the expression for current in the inductor. Find expression for current I2 of t in inductor. This is the question. Then the circuit is given something like this. You have a source, resistor, inductor, and a capacitor. So these value, this is opened. This is 100 volts, 10 ohms, 1 Henry, and 10 microfarad. This current is given as I2 of t. So let's try to solve this one. So first let's try to write at t is equal to 0 minus. So at t is equal to 0 minus, the switch is already on. So switch is on and capacitor and inductor are charged. So when this happens, the circuit will be, switch is on, this is the resistor, inductor, and the capacitor. So for infinite time, inductor will act as a short circuit and capacitor will act as a open circuit because they are charged. So inductor will be a short circuit and capacitor will be an open circuit. Inductor will be a short circuit and capacitor will be an open circuit. Now here you have I of 0 minus value, I2 of 0 minus. So this is VC of 0 minus. So because there is a short circuit present here, VC of 0 minus will be 0 volts. What is I2 of 0 minus? It is equal to V by R. Here you have a closed path, right? So this is I of 0 minus, I2 of 0 minus is equal to V is 100 by R value is 10. So this will be 10 amperes. Now let us consider the second case. At t is equal to 0 plus. At t is equal to 0 plus, if you consider this voltage is not connected. You have a resistor, inductor, and capacitor. You have an inductor and a capacitor. And what are the values of these inductor and capacitor? 10, 1, 10. So 10, 1, 10 microfarad is given. It is given as 10 microfarad, which is open. So you need not draw this also because switch is open. This 100 volts will not act now. So you just can eliminate this, or just you cannot take this because this is open. and inductor and capacitor are already charged, right? So this will be at t0 plus. Inductor does not allow sudden change of current and capacitor does not allow sudden change of voltage. So what is the value of vc of 0 plus is a 0 volts. Instantly it will become a short circuit. At that instant it will be a short circuit and this will be an open circuit. So I of 0 minus is equal to I2 of 0 minus is equal to 10 amperes. 10 amperes. I2 of 0 minus is equal to 10 amperes and Vc of 0 plus is equal to 0 volts. Now consider t greater than 0. At t greater than 0, you can write the loop equation as you can draw this circuit like this, inductor and a capacitor, and across this inductor it is already current source that is acting. That means it is acting like a current source which is charged to 10 amperes and inductor value is 1 Henry. This is 10 microfarad. Now if you write the equation, you can just write the equation as minus 1 di2. This is the value of I2. I2 of t. This is I2 of t. So di2 by dt minus 1 by 10 into 10 power minus 6 integral I dt is equal to 0. So you can write differentiating this equation. You can write d square I2 by dt square minus 10 power 5 I is equal to 0. That is I2. So it is, you can still write this differential equation as d square I2 by dt square plus 10 power 5 into I2 is equal to 0. This is a differential equation. D square plus 10 power 5 into I2 is equal to 0. If you solve this, you'll get the value of D1 as J316 and minus J316. This is, if you solve this differential equation, you'll get J316 and minus J316. D1 comma D2 is equal to. Therefore, you can write I2 of t is equal to K1 into 316t. Sorry, K1 into cos 316t plus K2 into sin 316t, because this is a 0 plus J316. A value is 0, so e power a value is not defined. So this is that. So you need to find the values of K1 and K2. Find K1 and K2. When you want to find the values of K1 and K2, at t is equal to 0, apply I2 of 0 is equal to 10 amperes in this equation. So I2 of t is equal to K1 cos 316t plus K2 sin 316t. So I2 is 10, K1 cos 0 1 plus K2 sin 0 0. So K1 is equal to 10. This is what you'll get it. Next, at t is equal to 0, you can differentiate this equation. So if you differentiate this equation, you'll get di2 by dt is equal to 316 K1 K1 is a constant value. Cos 80 minus sin minus a sin 80 minus, let's try to take this and differentiate it once again. So I'll take this in the next slide. So we can write I2 of t is equal to K1 cos 316t plus K2 sin 316t. So di2 of differentiating it, K1 into minus 316 sin 316t plus 316 K2 cos 316t. So di2 of 0 plus by dt will be k1 into minus 316 into sine 316 into 0 sine 0. So 316 into k2 into cos 316 into 316 k2 cos 316 into 0. So di2 of 0 plus by dt is equal to this value sine 0 0 cos 0 1. So this is 316 k2. So you need to find di of 0 plus by dt first. So let's try to find that di of 0 plus by dt from this equation. Yeah. So from this equation you'll get di2 of 0 plus by dt is equal to 10 power 5 I2 of 0 plus. So this is 10 power 5 into I2 of 0 plus is 10 power 6 ampere per second. So you got this as 10 power 6 ampere per second. So if you substitute di of 0 plus by this is d square I of 0 plus by dt. This is d square I of 0 plus by dt square. But we need to find di of 0 plus by dt. So once you substitute that, you'll get here di of 0 plus by dt minus 0 is equal to 0. That will give you di of 0 plus by dt value as 0. So 0 is equal to k2, therefore k2 value is 0. Now once you get this k1 10 and k2 0, substitute back in this, k2 is 0. So I2 of t is equal to k1 is, what is the value of k1? K1 is 10. So it is 10 cos 316t. So this is the expression for I2 of t for t greater than 0. I2 of t for t greater than 0. So this is how you will determine I1 of t and I2 of t. So in this session we have learned response of RLC series circuit and response of RLC parallel circuit. Also we have determined some, we have also solved some numericals. So if you like this video, share this video. So we have India's #1 study channels. As you can see, we have so many India's #1 study channels on Unacademy along with Unacademy Semester Exams. So please do like this video, share this video, use my code YSK10 and get 10% off on your next Unacademy subscription. Subscribe to Unacademy. Click on this bell icon to get more notification of my classes. And also let me tell you about this new batch starting, Evolve for GATE 2022. And hi Arvind. So we have top educators, Evolve for GATE 2022 and Ascend for GATE 2023. Hurry up, get subscription now. So once again, thank you all. Thank you for joining me this session. Karthik, Swapna, Soumya, Arvind Yanagandula, Panni, Shivakumar, Chandrakiran, Yemen Kumar. So thank you all once again for joining me this session on network analysis and transmission lines, response of RLC series circuit. Thank you.